Hi everyone, welcome back to Java 1 for All. In this video, we are going to talk about the binary search. Binary search, in this specific case, is a method that we have in the collections class that will return the index of the value we are searching or the position that we should insert that value. So let's see how that works by creating a new class, binary search test01. And we are going to start with a list of integers to make it easier to understand. Let's add some numbers, 2, 0, 4, 3. So the first rule that we have when working with binary search it is that your list must be sorted. So this is something that you have to do. If you go collections dot binary search and you search for the documentation, let me see this one for example, it says that if it's not sorted, the results are undefined. So every time you try to run a binary search, make sure that you have collections.sort before. Now we have the following rule. As I said, if we are searching for a number and the number is available, it will return the index of that number. But if the number is not available, it's going to return where that number should be inserted. But the rule is the following. So this is the mathematical formula that is going to return for us. So let's see how that works. Let's add a south here. And let's say that I'm going to search for the number 2. So if we have here index, we have 0, 1, 2, 3. And value, we have 0, 2, 3, 4. So let's search for the number 2. I need to pass 2 arguments. One is the list that is already sorted, and the other one is the key, in this case 2. So as you can see, number 2 exists and is located at the index 1. This is the value, this is the index. Now let's understand why why Java decided to have this -1. Let's say that I'm searching, for example, for the value 0. Let's say that we don't have this. Control Shift F10. If we didn't have this, you have 0, okay, but how do you know if the 0 is the position you should insert or if it's 0 is the index that you are searching for? Let's see another example. For example, if I search for -1, if I have the sorted, -1 should be at the position 0. But if I execute this, we have -1 because of this rule. So if we didn't have this -1 right here as the rule for this binary search, both results would be 0. So it would be impossible for you to define if the index is 0 or you should insert at position 0. That's why we have this rule, including this -1. So if you want to insert back, you have to do a little math based on this formula. And this is how it works with wrappers. In this case, classes that Java defined it, and we have the comparable available for us. Let's see how it works. For example, with our mangas. Let's create a new binary search test class. PSVM. Let's go to manga sort test01. Let's copy all of this, including the sort. Okay, so we have our mangas. If we execute Ctrl Shift F10, they are not sorted, so I'm going to move this up. I don't remember what attribute we are using to sort. Okay, so we are using price to sort these. This is the comparable available here. If we go all the way to the compare to, yeah, we have price. Okay, so I want to do a binary search. I will do the binary search. I will copy this new manga, Dragon Ball, and I will add it here. Let's say down here. Manga to search, and I will use collections dot binary search. I want to search in the list of mangas the manga to search, and south Ctrl Shift F10. So as you can see here, the position is 4, 0, 1, 2, 3, 4, and you have to be careful because in this case it looks like it's using equals, but remember our equals inside of the manga is not using price, so our equals is using ID and title. Now what happens if I change the price? So in my case now, let's say that Dragon Ball is $9.99. When I execute this again, Ctrl Shift F10, what do I have? I have -1. It means that the position we should insert this Dragon Ball is 0. So you have to be careful because the value that you are comparing is the one that the binary search is going to use to define if you need to insert something or if you need to just use the index that was returned. In our case, Dragon Ball, it does exist based on the equals we have ID4 and ID4, but the binary search is searching for the price. Basically, that's why we have to be careful when we are sorting the lists. So another example is if you are doing something different from what you have in the comparable, you have to pass the same, in this case, the comparator in your binary search. For example, here by default, we are doing the sorting mechanism for price. But let's say I don't want a price anymore. Let's say that we are sorting mangas dot sort, and we are going to manga by title. Let me create an attribute up here because we are going to keep using this again. Alt enter, manga by title comparator. Okay, so now we are sorting by title, but our binary search, it's expecting the things to be sorted by price. And just take a look. Here it was -1. If we execute again, we still have -1, but by pure coincidence. But if I change here, for example, let's say that I will add 30. Ctrl Shift F10 is still -1. Why is that? Because we are sorting by title, but our binary search is expecting to be the price. Now, what can we do is come here, and since this method is overloaded, we can pass the comparator as well. And now, Ctrl Shift F10, and the result is true. Positive, it means that we actually have Dragon Ball Z available in our list, but you have to be careful because now is not the price that's taken into consideration anymore. Now it's the title. So we only have 2 here because now that we're sorting by title, the titles, they match. But if I change this, for example, to A, Aragon Ball Z, and I execute again, it should be at position 0, in this case -1. So this is how the binary search works. I hope you are following everything that's happening here, and let's continue with more topics in the next video. Bye!